Hello everyone, my name is Peter Schaknat. I'm the Managing Director of Schaknat Electronic GmbH, and today we're optimizing a Mercedes-Benz Actros 1848. A quick word about the truck. This is a Mercedes-Benz 1848 with an OM471 engine, 12.8 liters displacement, inline 6-cylinder. This is a Euro 6C engine with 2,300 Newton meters of torque and the PowerShift 3 transmission. A quick overview of today's procedure again. We'll be flashing the truck again using the app. We'll also quickly do the initial measurements, optimize it, and once again tune it for fuel savings, so optimize it for eco mode. And then we'll do the final measurements afterwards. Today I'll also briefly explain a few things about the engine to you. We'll briefly tilt the cab for those who are interested, just to give you a few insights, show what the engine control unit is, and basically let you see the engine itself. We can also briefly explain the setup, how the engine is constructed. The truck is from the company Motschiedler. Roland Motschiedler, the head of the company Motschiedler, has also been a long time and valued customer of ours. Once again, the focus is on fleet optimization and significant fuel savings. I should also mention that the driver is an exceptionally good driver, someone who really pays close attention to fuel consumption, knows his routes very well, and makes a conscious effort to reduce fuel usage. That is precisely why we want to make sure we can achieve the best possible result for him today. The truck is used in a variety of ways. Sometimes it carries heavy loads, sometimes lighter ones. Sometimes I like to drive regionally into the Odenwald or even into long-distance transport. That's why it's especially important that we optimally coordinate the torque again, matching the engine to the transmission. But as I already mentioned, I'll do that with the app as well. Now we're going to walk around once. My colleague Basti is now going to tilt the cab. As I said, we're measuring here as usual. We've already secured everything. Here you can see the drive axle again. Here are the rear rollers, and here we can see our eddy current brake again. I already mentioned back then that we can measure up to a maximum of 5,500 Newton meters and 1,800 horsepower. If we don't reach that with this truck, that's fine too. But as you can clearly see, in terms of the fundamental basic concept, we are able to measure some pretty powerful engines right here. At the back we have secured it once again with these 10-ton tension straps so that it is properly and securely fastened and cannot move backwards. It is incredibly important for safety reasons that you do not pull back too much at the rear. Otherwise we run into the problem that during the measurement the shocks from the chassis are transferred directly to the bearings, and that is of course not ideal for the test bench. It's absolutely crucial that we have 100% traction. That's why it's always important. If you look down here, you'll see we've installed our hydraulic cylinder in the pit, which allows us to pull straight down with slip. This way we can go around the axle, come together in the middle and pull down with a maximum force of 5 tons. Of course, you mustn't pull down too hard, otherwise you'll have excessive power loss. Otherwise the tires heat up too quickly, but we always keep an eye on it. We have our experience values through the hydraulics. With 80 bar, we usually get good traction values. Basti will quickly tilt the cab now, then we'll take a quick look at the engine, and after that we'll already do the first initial measurement. You can see here as well, it has standard drive shafts. The EcoWay has them as standard too. The customer owns many different types of trailers, so his truck is equipped with an adjustable fifth wheel plate. This makes it height adjustable, which allows him to use it with his entire variety of trailers. As mentioned, the EcoWay has an OM471 engine with a PowerShift 3 transmission. The big difference between the PowerShift 3 and PowerShift 2 transmissions compared to the old MP3 Ikewissen models is basically that PowerShift 2 had a pull-type clutch, and the major difference with PowerShift 3 is that it has push-type clutches. As a result, Mercedes was able to eliminate about 80% of clutch wear because the clutches are push-type and the release bearings aren't under such high stress. In the past, they had quite a lot of clutch problems because when you were stopped at a traffic light, you didn't disengage the clutch. It's as if you were constantly standing on the clutch. With the PowerShift 3, they have significantly fewer problems than with the old PowerShift 2. Now I'm installing an engine. It's a straight 6-cylinder, an OM471. You can see it here at the front. I always notice it starts with an A, then comes 471. So that's always the engine number at Mercedes-Benz. The engine series, so the engine actually comes from Freightliner, or rather Detroit Diesel. Mercedes actually bought Detroit Diesel. The engine actually comes from the Americans. The structure of the 470 engine with 10.7 liters, the 471 engine with 12.8 liters, and the 473 engine, which is available here on the European market with 15.6 liters, all basically have the same design. So I would say, of course, the engine size is a bit different because of the displacement, but if you tilt the cab up, the basic structure is always the same. That's also the nice thing about Mercedes. Even when we optimize the details, we don't have to reinvent the wheel every time because the engine components keep repeating themselves. You can see it here. The Actros has an external common rail pipe, which you can see quite clearly here. Here the fuel pressure is built up in the pipe and goes directly to the injectors. Mercedes uses what they call the X-Pulse system in this engine series, so they build up fuel pressure in the rail with this X-Pulse system. Fuel pressure is built up, and each injector adds another 200 bar of fuel pressure. A total pressure of 2,700 bar, so you can easily calculate 6 cylinders, 200 bar per injector. That's 1,200 bar of pressure generated by the injectors. And then I have a fuel rail with a base pressure of 1,500 bar. The big advantage of this system is these high pressures. They make the injection process very efficient. In the past, the fundamental problem with the pump lines and nozzles, which Mercedes also used, was that the system was predominantly controlled by the duration of the opening times. Here you achieve a very high base pressure. You can do multiple injections per stroke, pre-injection, main injection, and post-injection. For example, it's important when regenerating the particulate filter. There are other injection cycles, other regeneration cycles. You can often hear it in the engine when the particulate filter is being regenerated. The engine often runs a bit rougher or a bit harsher because it increases the temperature to burn off the particulate filter. I'm always a bit cautious when it comes to fuel pressure because the first generation of the MP4 Actros had brass sealing rings in the injectors, and Mercedes had a lot of problems with that since they became internally leaky and many injectors had to be replaced. They've changed that by now. So, knock on wood, with the MP5 we don't have any issues anymore. MP4 starting from engine generation 3 or even from 4, 2016 is engine generation 3. That's when we actually installed the good injectors, and since then we haven't had any more problems. At that point they also increased the fuel pressure to 2,700 bar, which you still have in the new variants today. That's why I say when it comes to injection it's just very, very efficient. You can tell compared to other manufacturers, Volvo, Scania, they're all following suit because they also see that we have to keep reducing fuel consumption. With a system like this, it's always important that you have clean fuel. If you have fuel contamination, because the injectors, the nozzles at the front are so fine and inject at such high pressure, you'll ruin the injectors in no time. So that's always something to keep in mind. It's very important. In Germany we have fewer problems, but abroad it can happen that injectors fail more quickly simply due to poor fuel quality. So as I said, we don't increase the rail pressure in the software in order to protect the injectors. That way we don't overstrain the injectors. So we keep the rail pressure at stock levels. In some situations you can make adjustments, for example when using cruise control. If you're driving at 85, you can calculate the axles, determine the throttle position, and maybe increase the pressure by about 50 bar in the partial load range. That way injection becomes a bit more efficient. But that's just my experience. With these engines, you don't necessarily have to do that. If I really want to get the maximum out of it, I can still make those changes. I've run a lot of tests here, trying to achieve the lowest possible consumption. But what's always important is that longevity comes first. Obviously, we don't want to damage the engines by doing this. That is why, as I said, we don't touch peak pressures whatsoever to keep the system as durable as possible. Down here, I don't know if you can see it. Is the engine control unit still installed? Maybe you can see it quite well down there too. We also repair engine control units at our company. So as I said, if there's ever a need, engine and transmission control units, if something breaks, we can repair them. We can also test the control units and patch them again. Of course, it's really badly installed down there, so it's hard to reach, but obviously you just need a pit. All right, so let's take another quick walk around. This here is the exhaust side. As you can see, we have pretty large particulate filters. You can see them here with eBlue. The engine has exhaust gas recirculation, a variable turbocharger, and with SCR only, so a particulate filter with the eBlue system. You're all familiar with the tiresome topic of the retarder. You can see them here. As I said, the coolant lines. The retarder, the coolant is sludged up on the inside. So both internally and externally there are leaks. This also becomes noticeable as a result. We've often had customers where the workshop said the vehicles were 100% fine. We measured them on the test bench and simply couldn't measure any power anymore. And that's exactly when we had these issues where the coolant became sludged and the retarder was always slightly engaged. And things like that can also be perfectly detected on our test bench when such issues occur. And you can also use it to rule out errors and similar problems. MP5, great. I haven't had many problems with it so far. As far as I know, the retarders haven't really been changed much. But Mercedes is very accommodating, so they offer relatively long goodwill and warranty periods. You have to give them credit for that. If something does break on the vehicles, Mercedes really makes an effort to get it working again. Then here I installed the variable turbocharger, here with the boost pressure linkage. A variable turbocharger also works with adjustable vanes. So in other words, at lower RPMs it closes so that I quickly get high pressure, bringing air into the combustion chamber at the bottom end, and then at higher RPMs it opens up again. With variable turbochargers, you often have the problem that after 400, 500 or 600,000 kilometers, depending on how they've been used, the linkages can get stuck, and they can also be slightly rusted, making the linkages stiff, which then often leads to turbocharger errors or boost pressure errors being displayed. So as I said, they tend to wear out more on the mechanical side. The turbos themselves actually keep running, but these are just little things, little details, I would say. So as mentioned, up here, the big part is the EGR cooler, meaning exhaust gas recirculation. I know the opinion of Scania drivers, everyone who doesn't have EGR. It's also the case I burn the exhaust gas again by mixing it in. It's definitely true. This causes coking in the combustion chamber. It's not the optimal solution, but manufacturers are increasingly trying to move away from exhaust gas recirculation and instead control everything more through particulate filters and AdBlue. But of course, there's one thing you shouldn't forget. If I remove the exhaust gas recirculation rate, then the thing needs significantly more AdBlue in comparison. At Scania, they got rid of EGR, but as a result, they have much higher AdBlue consumption. It's crucial for manufacturers to comply with their Euro emission standards. That's just as important for us. When we optimize the vehicles, they fully comply with the Euro emission standard. The rear NOx sensor measures compliance with the Euro standard. But if you notice that the engine is emitting more soot, a warning light will immediately come on in the cockpit. Also, in terms of the Euro standard, we are 100% on the safe side, fully compliant with the Euro norm. All right, up to this point, we have explained everything about the engine. And I must say, I think it's a very robust and reliable machine. I've heard of very few major damages with these engines. Mercedes has an incredibly good limp home system. If the system detects any drop in pressure, or oil temperature, exhaust temperature, or any drop in pressure from the fuel injectors, they immediately reduce the power output and switch over to limp mode right away. The injector doesn't even get the chance to inject too much fuel, break through, or spray damaging holes into the pistons. Things like you see with the MP3 with holes in the pistons basically don't happen with these engines, because the design has already been changed so much that this really can't happen anymore. And the electronics are now so fast and so smart that they can immediately cut the power and switch to limp mode in these situations as effectively as possible. At the latest, it's clear when the driver experiences a loss of power, pulls over, and calls his boss, the fleet manager, or the workshop. Then they can react quickly as well. All right, as I said, I hope you found it interesting. A brief insight into the engines and Mercedes in general. So I'd say let's tilt it back, start the initial measurement, and continue with our optimization. We are now performing the initial measurement. I'm aligning the axle again. For the test bench, it is very important that it knows what engine speed we have up front, because not all of the rear axle ratios are the same. If a longer axle is shorter, I align it at 1000 revolutions. Now we have exactly 1000. The measurement procedure is the same as before. We're taking measurements based on engine speed, once from bottom to top, once fully accelerated through, up to the maximum engine speed, so you can see on the test bench if it forms a curve anywhere or if it drops off somewhere, so that we have the road simulation available. I can also see how it actually runs on the street. Then we will go ahead and start the first measurement. Now I am braking it once again. Okay, I have now opened the throttle up all the way again. Now I am applying the brake, and the eddy current brakes are what's allowing us to steadily build up the necessary torque. Now that the turbo is fully spooled, we can officially start the run. So, as you can clearly see, this truck is officially rated for 480 horsepower, and it also has top torque. In our own testing, we've now measured an actual output of 474 horsepower and a truly substantial 2,517 Newton meters of torque. The truck is specified with a top torque of 2,300 Newton meters in the lower gears, and in the higher gears with top torque 25. But I still only do 2 or 3 initial measurements. Every now and then, depending on how I disengage at the top, it's always important that we calculate the power loss and the torque correctly. I'm going to do 2 more measurements now, and only then can I see the average values to make sure the torque is really correct. We've also had cases where if I brake too early and disengage too late, I still end up with a difference of between 50 and 100 Newton meters. To rule that out, we always do 3 initial measurements. So now we'll do the other measurements. For this customer, it's now about fuel consumption, so that works for me. The employee will now use the app to flash the software again. Let's just quickly go over there now. It's also a nice different app. It's also compatible for us in the company when we upload the data sets online again. You can see it for yourselves. Anyone can easily flash it on their phone. So now you just select it again. Connect there with the dongle. Then the system automatically connects to the truck once again. You are likely already familiar with this process as well. Now the user can go ahead and navigate directly to the engine control unit. He's now flashing the eco optimization. This will take about 10 minutes again, and afterwards we'll immediately do the initial measurement, do 3 initial measurements again, and then we'll look at the results together. We made sure that the torque is good at low revs, that the eco drivers can shift up early again, so that we can get the most out of the fuel consumption. And as I said, we'll take a look at the initial measurement together afterwards. We've now done the initial measurements. So you can see them up here now with the curve number in 10th gear. So just as we actually set it up again, the 300 Newton meters with the top torque again. So you can see we now have 2,296 Newton meters stock in 10th gear and optimize 2,620 Newton meters. If I now add this 200 Newton meters top torque, number 11.12, then I'm at 2,800 Newton meters. And there we are again at the topic of the OM471 engine. The axles were rated up to 2,800. So in other words, Mercedes-Benz installs these industrial engines with up to 2,800 Newton meters straight from the factory. So as you can see, we're actually exactly on target here. You can also see now, especially at the lower end, it has a much nicer torque curve. So I would say from 900 to 1,000, it already pulls up much more smoothly. This also means the driver can upshift much earlier again. Of course, if he pays attention and puts in the effort, he'll be able to save even more fuel. Sure, 300 or even 320 Newton meters, which is what it is now, you really notice the difference in pulling power. So it's a completely different driving experience. We've also optimized the transmission as well. A KW needs about 1,000 kilometers to adapt until the engine and transmission are fully synchronized with each other. I'll also tell the driver that during certain shifting cycles, especially in the first 1,000 kilometers, if he thinks he could shift, he should occasionally help out manually. If he thinks, for example, okay, I can manage to shift at 1,200, he should just go ahead and shift once, so that the transmission can remember those parameters. You can control this pretty well through throttle input, but sometimes trucks have situations where you're not 100% sure whether you should shift up or not. Often the driver's input is just what's needed to improve or speed up the learning values. As I said, I'm really satisfied with the results. I'll also talk to a customer who pays very close attention to fuel consumption. We'll take a look at everything after 4 weeks. Where will we stand in terms of fuel consumption? Depending on what the truck is hauling, the trucks are already running quite efficiently. So I would say I probably couldn't get another 3 liters out of it. I'd say if we can consistently save about 1.5 to 2 liters steadily, I'd be more than satisfied. I know with current fuel prices at a net of €1.70 or €1.80 from what I've heard from customers and what they're paying at the pump. 2 liters is almost €4, net or gross. Either way, it's €4 I can save per 100 kilometers. Of course, over 100,000 or 130,000 kilometers, which is what a long-haul freight company covers, that really adds up to a significant amount of money these days. All right, as I said, we'll leave it at that. My employees will now unhook the truck, take it for another test drive, clear all the error codes again, and check if everything is in order. And yes, I'm quite satisfied so far. We have reached the end of our video once again. The customer, he already knew me because he has a pretty large vehicle fleet. We've already optimized quite a bit for him. Today, he was particularly interested in the extreme fuel consumption and the performance, whether the engine really has the necessary power in that area, just to check everything thoroughly. I certainly hope you found it interesting because I explained a little bit about the engine, the transmission, and the truck in general to give you a bit of important technical background. I want you to see that we genuinely think about how we set things up, what specific operating conditions we focus on for the engine. What can the engine actually handle? What can potentially damage the engine and what it absolutely can't? As I have already mentioned, with the Mercedes OM471, which is an engine we work on a great deal, it's always very interesting for me to explain this information to our customers. We are truly glad that you watched our video. If you found this topic interesting, feel free to visit our website at www.schaknat.de. You can also send us an email, give us a call, or write to us on WhatsApp. Be sure to subscribe to our YouTube channel. I'm really thrilled that it's been so well received. Thank you very much for watching. See you next time. Thanks, bye.